have this HR15 narrow hybrid machine, and the fault with this is every time when we replaced this board it gets blown. So something is happening and that board it's failing very often. So I'm trying to do some checks and see what could be causing that. There's a new board here that failed straight away, and the way it's failing, so if I start a diesel engine, it's gonna rev the max revs. So something is shorting out on the board and pulling this throttle all the way in as soon as you start a diesel engine, and the motor controller shuts down after a few seconds. So that's the way it's behaving. So I do think the problem maybe is with the grounds, because we do have a 48 volt ground and we have a 12 volt ground from that 12 volt battery here. So 12 volt ground and 48 volt ground here, and the way the board is working, this wire, this a single wire, comes from the motor controller over there. It's controlling engine speed. So the way it's controlling that is by pulling the voltage down on that board, and we do have a pull up to positive rail on that board, and the positive rail pull up is up to battery voltage. Okay, so if we have a different ground reference between the 48 volt ground and 12 volt ground, that's gonna have such an input on the board that it's gonna keep blowing that transistor here. And there is a fuse holder here. That fuse holder connects those two grounds together, one ground here on the input side and a ground on the output side. That's 2 amp fuse should be there. The fuse is good, so both grounds is linked together. So I am thinking the possibility is that the problem with the ground connection on that plate over there, so there is a plate here at the base, so there is a ground connection, or there is a ground connection. Let's see if we can get it. There's a ground connection on the engine, and that is not looking good at all. I'll see what I can find and what I can do to make it better, and I'm gonna try to possibly see if I can fix this board, and if I can fix the board I will try that fix for my testing. So I'm not blowing every time the board, but I'm gonna try to repair it a few times until I'm happy with the fix, and then I'm gonna fit a new board afterwards. Just remove the board from here, and you can check the board if you fit your multimeter probe onto TPW and between ignition alternator. Okay, hopefully you can see. Okay, and if you look on the multimeter, if you measure resistance, look, is a short circuit. Okay, so the short circuit, that's why it's revving high all the time. So the short circuit between input and output on that transistor here, and if I check the control side, again is a short circuit between the output and the control side, and that's why the motor controller is shutting down. So I'll try to see if we can replace that transistor for my testing, just to have something to test the machine on, and possibly go that way. Okay, so I got my board out, so I'm gonna try to clean. You see there is a protective layer on the surface. I'm gonna try to clean this out, and there's a 3 pins I need to work on. You can see there is a resistance in between the input and output. Oh no, not input and output, sorry. There is a resistance between positive input and a control side, and it's about, I think it's 1000 ohms, so it's 1001, and we measured 2 ohms or very close to short circuit, so that's just proving the point that the problem with that resistor. And because the short circuit has been measured with the wires removed, so nothing else should be shorting this out. So let me try to see if I can clean this off, and I can try to get my new transistor in and test the board. The parts has been desoldered, and the first thing you have to remove the heatsink, and then I get the transistor out, and that is my new transistor here, and we'll reassemble now. So the pads are clean, ready to be soldered. That's the way this side looks like. There's a layer of protection here. I will leave it that in. So reassemble new part, and I will try to see if that's going to work. Under this protection layer, I found some solder. So remove the protection just to make sure everything's cleaned up and no ways to short it out. So it's all cleaned up now, ready to be soldered for the new parts. So new parts are soldered on. It's not the best looking soldering, but should do the trick. So that's assembly. Let's test the board and we go from there, I guess. So I'm gonna check resistance now between ignition alternator and the wired TPW2, and that should be around 1000 ohms, and that's what I have. Nearly 1 kilo ohm, 0.99 kilo ohm. This board fitted on, so this is the one we repaired, and I'm gonna try to test the machine, see what's gonna happen. Switch the machine on. Going to preheat. So when I'm gonna start the engine, I would expect the throttle solenoid to pull in and control the revs. So let's try 1, 2, 3, start. That's interesting because I have no engine stop, but the throttle solenoid is working. So as I push this in, that's stop the lever to cut the fuel off the engine starts to drop out, so the solenoid moved and pulled the lever in. But I have no engine stop. Normally when I have no engine stop, that means the fuse here is gone. So that fuse should be 2 amp fuse, but it's been replaced with 5 amp fuse. It does look good, so maybe it's a problem somewhere else. Maybe it's actually the problem with the link here. So I'm gonna measure the voltage on the stop solenoid feed, so let's try. Okay, so there is no feed in solenoid. So next thing I'm gonna measure the voltage to stop relay. So I'm going to measure the voltage on the wire STPC plus, and we should get 12 volts over there when we start the engine. So let's turn the machine on. Okay, so we have no voltage going to that relay. That's why the engine stop doesn't work. And that's where the feed comes from. Oh, maybe that's why. Look, the cable is loose. Yeah, so that cable is loose. Maybe that's why we don't get the voltage in it. Okay, let's fix that. Okay, so the wire has been fixed now, so that's tight. So I'm still measuring the voltage feed into stop relay. So let's see if we're gonna have some improvements. So let's start the engine. Alright, that's perfect. So the stop is working now. So the problem was a loose wire on a stop signal to the timer relay. So that's fixed. So I'm gonna try to use the machine a bit more, see if I can get that board to fail again. So I drove the machine for about 5 minutes at the high revs, and once I released the trigger on the drive joystick and the revs gone down to idle, the starter motor has engaged for a split second, and I had the engine shut down, and now I have error codes present, so error 21, 23 and error 27. So it's still showing the engine's running, but it's not. So I think what's happened is that board has failed and it blew the ground fuse. So the board looks okay, there's no visual signs of damage or anything. And that fuse has gone. So yeah, the board failed and blew the. Normally when the board fails, it blows this fuse as well. So let's remove the board. Let's get repaired, and we're gonna do more testing on it to see what's actually caused that failure. My colleague has advised to look onto electric motor, and the way we found is when I started the machine up, we seen the sparks inside the motor. So we were looking inside the motor and we started up machine, and it blew the fuse straight away, but at the same time we produced the sparks inside, so we was able to see visually. And then later on we found that nut at the bottom. Sitting right there. So I'm gonna change the motor because I don't know what sort of damage it has done inside. So I'm gonna replace the motor, and we're gonna test the machine with the new motor, new board, and hopefully that's gonna be fixed.